Okay, so if you can't see because of light, I think you are you are getting me clearly. Yeah. So I'm saying in mathematics, binary operation is also called the dyadic operation. Dyadic operation. This is the term operation. So it's a rule of combining two elements called the operand to produce another element. That is general definition of a binary operation. More precisely, as I've already alluded to, a binary operation on a set S is a mapping of the element of the Cartesian product on S by S to S, on S by S to S. Okay, so here the function, if you have a function f such that S multiplied by S, it gives S. This is what we call the mapping. You can say that S is being operated or rather mapped from this operation to represent a single product. And as a result is also S which is operated on this side. Okay. For some of the students, they may argue that generally in mathematics, when you say S times S is equal to S squared, this is not in that case. But what we are simply saying is that we are relating functions in that when we operate these groupings, the result should be equal to the same. On the other hand, we said what is on the left side should be equal across the equal sign on the right what side. And if you operate such operations and as the results are for the same element, we say is we have mapped that element. But in this case, when we operate the element of the same and results the element in the same manner, or the element or the product is the result of the same, it has a specific and important property, what we call the closed operation or internal operation. Okay, so simply what I'm trying to put across is that since the results of function f s by s is equal to s, and these results of performing the operation, okay, I'm here now. Since the results of performing the operation on a pair of elements such as S is again an element of S, the operation is called closed or internal binary operation on S. Or sometimes it is called having the property of closure. Okay? Are we together there? Okay. So since the results, when we perform an operation and the results are of the same element, such an operation is called the binary, is called the closed binary operation or internal binary operation, or sometimes having the property of closure. I think we are clear there. Okay? So if f is not a function, if f is not a function but a partial function, then f is called a partial binary operation. A partial binary operation. So we have the closed or internal binary operation and the partial binary operation, and this is being known after operation. We are saying when we operate, we perform the result of performing an operation on a pair of elements is again an element of the same operation. Then this operation is called the close operation. And an operation is called the partial binary operation if a function is not a function but a partial function. It's a partial function. In this case, it's not a complete function, but it's a partial function. Then that function is called a partial binary operation. Okay, follow me well. Here now, when somebody can say, how can it not be a function and be a partial functions? What am I simply trying to put across here is that this function is not complete. In other case, there are some figures or digits that you cannot operate on. The results will become what we call the syntax error or undefined. Such operations are called partial operation because in some field of numbers, it fails to operate. It fails to operate. So such functions, they are called partial binary operations. Partial binary operation. For example, if you have 2 divided by 0, is undefined. So such functions, they are called partial binary operation. So here it says if not a function but a partial function, then f is called a partial binary function. So for instance, okay, take example. When we divide a real number, a division of real numbers are called the partial binary operation. The reason being that no one can divide by a 0. This is what I've already talked. If you have a divided by 0, the answer is undefined for every real number of a. So if a represents any real number, then we divide such a number by 0. The result is undefined. But when we divide a over a, which is a is equal to 2, or a over b, a is equal to 2, or b is equal to 3, we'll be able to find the solution. So in this case, because these real numbers, when you divide 0 is also a real number, and the operation is undefined, we are simply saying this becomes a partial operation. You can't complete the operation of all real numbers. Some real numbers will fail to operate, and the good example is 0. Okay, so in both universal algebra and model theory, the binary operations are required to be defined on all elements of S by S. Okay. Let me say something here. What do I mean when I say in both universal algebra and the model theory, the binary operation are required to be defined on all elements of S. Okay. You may agree with me that, or from the general understanding of binary operation, we say the operation that will give, from the general understanding of binary operation, we are saying if a function is a binary operation, then it should be able to give you a result, not undefined or syntax error solutions or no solutions. Such a function is not a binary operation because it fails to produce a result. Okay, so when I say the model or the universal algebra field, the binary operation required to be defined on all elements of S by S. This is simply mean that if it is a binary operation, as I already said this, uh, it should be able to operate on real number system. Okay. So in a binary operation, mathematical representation, generally we are using a symbol which is a star. Okay. So this star symbol is the one which we are referring as a binary operation in representation of symbols in mathematics. So what are we simply saying? We are simply saying if this star is a binary operation on some functions, then it should be able to produce a result. Okay? But before I go further, today as an introductory, I'm not solving any questions. So I need to give what is involved in relation to set. So a binary operation in relation to set, it deals with the properties, and these properties are what we call the associative, the commutative laws. So these are the cardinal laws that you must abide by as a student for you to perform a binary operation, because it's a combination of concepts on sets and binary operations. So please take note. If you are not familiar with the laws of set, of De Morgan's law, associative law, and commutative law, please revisit the concept on sets. Otherwise, you'll not be able to perform these set functions. So, uh, mm, okay. Mm, I think by now you know what is involved. Okay. So I'm going to remind you some laws in set as property of set. In set we come of what we call the associative law. So the associative law of set, it says if you have an operation of set, uh, such as if you have set A, if you have set A and set B, okay, yeah, okay, just take note. My pen is not writing well, and also my handwriting is not as such as perfect, because as you went, okay. So if you have set A and set B, okay. The associative law of set, it says when you operate these two sets, right? When we say A intersection B, okay, this should be the same as B intersection A, okay. This is what the law is saying. This is what the law is saying. It must be the same, okay. So it is when you relate to binary operation, it's just the same. If you have A multiplied by B should equal to B multiplied by A. If these results are equal, when you operate A by B on the left side is equal to B times A on the other right side. This is called the associative law. and these results are not the same on both sides, is not qualified to be associative. Okay? Associative. Okay. On the other hand, the commutative law, it says it deals with the operation of grouping. If you have three given sets, okay, this is number one, this is number two, okay. If we have the two given sets, three given sets A, B, and C, if you have this set, and when we operate this set, for example, if you start to operate with A intersection B, rather union C, this should be the same as B intersection C union A. Are we together there? Or when you say A intersection B intersection C should be also equal to B intersection C intersection A. So these are the just basic or general concepts on a commutative and associative law. So if we operate this, when we start with A and B in combinations, it should be also be the same when we operate with the combination as B and C. So you can see, either way, it should give you the same results. But if this is not giving you the same results, then it's not qualified to be commutative. Okay, so having these basics, we should also be able to identify which operation in terms of addition, subtraction, multiplication, and division are commutative by nature. Okay, so you can test these. If you have these operations in mathematics, you can say, if you are given a function, for example, uh, you have 2 multiplied by 5. Okay, this should equal to, either way, whether you start with 5 multiplied by 2, you can say 2 multiplied by 5 is equal to 10, and this should be equal to the same on the other hand. 5 times 2 is equal to 10. This is called associative. But if in this side, one or this side, the answers are not matching, then this will say it's not associative. Yeah, this should be the same. Okay, let's take just one illustration. Okay, if you have 4 divided by 2, okay, if it's the same when we say 2 divided by 4, 2 divided by 4, 4 divided by 2 is equal to 2, but 2 divided by 4 This is equal to half, which is equal to 0.5. So in this case, you can say that 2 is not equal to half. So this does not qualify as associative. Okay. So having this concept, now we can perform the binary operation given any questions because we have the tips at hand. Okay. Well, as I've alluded to, today I'm not representing any questions, but only to introduce and give the concept. Okay. So if you haven't understood, I think I was clear when explaining, and also my notes, I think you are able to see my notes and read for you to understand better. Okay? Remember, you need to be focused and be endure. Don't be backslided as a student. Otherwise, everything is just simple. It's just the matter of going through sorting out what is difficult for you, pay attention, and what to give more effort to. Okay? So just as I've said, just subscribe to my YouTube for more questions and lessons are coming, unsolved questions. Remember, we solve tutorial sheet from various university in the country. So don't miss what is important for you. This is your future. Be focused. Okay? Uh, if you have any questions, text me on the WhatsApp number which ends with 555 and call for the one which ends with 12 for the course. I will be able to reply to you instantly. WhatsApp and send a question where you find challenges. Otherwise, soon I'll be presenting lessons in solving questions based on the binary operation, having outlined these few concepts. Basically, I think it has helped well. Okay? So for now, I'm ending. But for any questions, please WhatsApp me on the number 0976 837 555 and call me on 0770 135912. These are my numbers that I'm using. Please WhatsApp me for any queries. I'll be able to reply to you instantly. Okay. Don't forget to subscribe for more benefits. I'll solve the example and questions, and exam questions tutorial sheets are being solved on my channel. Bye bye.